In this lesson, we are going to be talking about something called properties of exponents. I'm going to be introducing you to some very simple concepts, but they're going to be put into a little more difficult concepts when it comes to example questions. So I'm going to first start off under notes. You should see how I give you something called x to the fourth times x to the third. Now, this is multiplying exponents bases when the exponents are the same. The x is called the base, the 4 and the 3 are called the exponents. So as long as the base is the same, meaning they're both x's, what I show you in the notes are whenever the base is the same, it's the exact same thing as saying x to the fourth plus x to the third. And you just add these two to get x to the seventh. Now, sometimes they're going to give you a couple parts to it. Let's take, for example, question. Let's say we have an example question of 5x to the eighth, y to the second, x to the ninth. Okay, so technically, if I were to separate everything, I'm going to have 5 times x to the eighth times y to the second times x to the ninth. And this might help you to be able to visually see what in the world's going on. So 5 times just nothing is just 5. And what I like to do is I like to cross everything out so I know what else I have to deal with. I have an x to the eighth and I have an x to the ninth. I can multiply these two because the bases are the same. Now remember, look over here. When the bases are the same, you add the exponents. So you are going to get 8 plus 9 is 17. And then you're just left with that y squared. So this is the simplified version of this. Let's take another example question. Let's say we have 2x times 4x to the third y. See if you can pause this video for a second and try and figure out what this answer is. Pause the video and go ahead and try this. All right, so if you went ahead and tried this right now, you should understand that there's only one really thing that you're multiplying together, and that is, or two things. You're multiplying, anytime you have numbers, you're always multiplying those. 2 times 4 is 8, and like I said, I like to cross it off so I know what else I have to do. Now the next thing, there's an invisible 1 on that x. And these two have the same bases. Now remember, when you multiply, you add the exponents. 3 plus 1 is x to the fourth. And then I can cancel this out. And then I have my y. All right, there's your simplified version. Let's do this. Let me show you conceptually what the heck is going on here. Let's say we had x equals 2 and y equals 3. You're going to see if I plug a 2 into this x and a 3 into y, it's the same thing as this simplified answer. If I plug a 2 into this x and a 3 into the y, you're going to see how it's the exact same thing. So look, watch. I'm going to rewrite this equation. I'm going to have 2 times, instead of an x, I'm plugging in a 2. The only reason why I'm doing this is to explain to you these two values are the same. This is called the simplified version of this, but you still get the same exact answer. Conceptually, everything works out. Times 4 times, I'm going to plug a 2 into here, so 2 to the third times 3. Okay, I'm going to do some of this on my calculator. I'm doing some of this in my head real quick. 2 times 2 is 4. 4 times 4 is 16. 2 times 3 is 8. 8 times 3 is 24. So I'm really going 16 times 24. 16 times 24 is going to give me, this value is equal to 384. Now watch, I'm going to actually get the same exact value. If I do 2 to the 4th, 2 raised to the 4th is going to give me 16. So this is 8 times 16 times 3. Now look, 8 times 3 is 24. So I have 16 times 24. Look, 16 times 24, when I did this long way, 16 times 24 is going to give me this value. That's why both of these check out. It's the exact same thing. Conceptually, I am teaching you how to take an equation and shrink it, simplify it to get a much smaller version. Think of it like this. Think of it as like, let's say you had 50 over 25. This would equal 2 over 1, which is equal to 2. This, if you do it on your calculator, is the same thing as this when you do it on your calculator, which is the same thing as this. But when you do this, you're never writing an answer as 50 over 25 and leaving it. You're always writing it in a simplified version. Now, properties of exponents, I'm not going to do this step with every single thing that I'm going to show you right now, but I just want to show you that with exponents, properties of exponents, it's just a simplified version of the original question. You're not changing any values at all. All right, so with that concept, I'm going to go ahead and teach you about a couple more concepts now. But I'm not going to go through and plug in numbers for each variable I just kind of proved to you how they were equal. But to spare you the time, because I know a lot of people will probably zone out after that, I'm just going to go through the steps now, or the concepts. So the next one on your notes, I say x to the 4th to the 3rd. Now look, I go ahead and I elaborate on this because if you have x to the 4th 3 times, technically you're having this x to the 4th times x to the 4th times x to the 4th. Let's do like this. Let's say you had 2 to the 3rd. 2 to the 3rd would be 2 times 2 times 2, because that's what exponents are, which would give you 2 times 2 is 4 times 2 is 8. You would multiply this. Same thing with this. X to the 4th, all of this 3 different times. Now remember, from the last concept, what happens when you multiply bases that are exactly the same? You add the exponents. 4 plus 4 plus 4 is x to the 12th. So a shortcut that I show you is whenever you have an exponent outside of a parenthesis, you just multiply. 4 times 3 is 12. But then I give you an example question. With the notes, pause the video, see if you could do this example question. X squared, y to the 5th, all to the 3rd. Pause the video and see if you can do this. All right, so if you pause the video, you should have probably been able to see that this is going to give you x to the 6th, y to the 15th. The reason why is because what I just showed you, the shortcut. Whenever you have exponents, you have to obviously distribute this to both of these. 3 times 2 is 6, and I told you I like to cancel it out. After I'm done, so I know what I have left to do, I have to distribute this 3 to the 5. 5 times 3 is 15. This is the simplified version of this. So if you were to take, let's say x equals 2, y equals 3, if you plug this in and do the math, to get this one number and cube it, you're going to get the exact same thing as doing this equation, or this this in green right here. Same exact thing is going to give you the exact same values. The next thing is a fraction. And I say x to the 3rd over x to the 8th. Whenever you have a fraction, technically you're doing this. You're taking your top number and you are minusing your bottom number, which is going to give you x to the negative 5th. And I'm going to teach you in a second, whenever you have a negative exponent, because this is technically over 1, you just flip this and it becomes the reciprocal to get 1 over x to the 5th. If I lost you doing this, I give you an example. I say, let's say we have 3x's here. And let me draw out 8 here. 1, 2, 3, 4, 5, 6, 7, 8. And then whenever you have the same thing in your numerator and denominator, you can get rid of it. So look, you have 3 x's here, you have 3 x's here. Technically, you can get rid of these 3 and these 3. And here's your visual of what you have left over. But there's not 0 here because there's an invisible 1. So it's 1 over, how many x's do you have? X to the 5th. 1 over x to the 5th. See? Gives you the exact same answer. All right, now with this, I give you an example. Try and pause the video. 2x to the 5th over x to the 3rd. See if you can do this question. All right, if you pause the video, you should have gotten 2x squared as your answer. If I lost you on how in the world you get 2x squared, I'll show you 2 different ways. First way is, look, let's do this conceptually. Whenever you have bases that are the same, you take this minus this. So technically, you can rewrite this as 2 times x 5 minus 3, which is equal to 2x 5 minus 3 is 2. 2x squared. That's your answer. Now that, if I kind of lost you, think of it like this. You have a 2, then you have 5 x's. 1, 2, 3, 4, 5. Over, and you have 3 x's. 1, 2, 3. So if you cross out 3 x's on the bottom, you can get 3 x's on the top, and you have 2 times, how many x's do you have? 2. That's how you get 2x squared. So whenever you have a fraction, you always subtract your numerator exponent from your denominator exponent when your bases are the same. And then as you can see in your notes, in a little bit, after I go over a couple more concepts, I am going to give you a couple example questions that are as difficult as you'll have today. But before I do that, I say x to the 0th power is equal to 1. Or let's say x, y, z, a, b, c, and let's just make some of these exponents all to the 0th power. Do you know what this equals? 1. Now the question is, why? On the notes I say x to the 0th power, or I should have said anything to the 0th power equals 1. The reason why it equals 1 is because of this. What's your invisible coefficient in front of this? Or what number is invisible in front of any variable? A 1. So technically I can rewrite this as 1 times x to the nothing. And if I don't have any x's, this is gone. So I'm just left with the 1. Technically, what's in front of this this parenthesis? It's a 1. It's 1 times all of this. But look, if I have 1 times this whole thing to the 0th power, that 0th power means there isn't anything in there. And I am left with that invisible 1. That's why conceptually anything to the 0th power always equals 1. Look at the example question that I give you. I give you a parenthesis and I say 100, x to the 0, y to the 0, z to the 8th, all to the 0th power. And I say simplify. Well, look, this 0 power technically gets distributed to this 100. It gets distributed to the here. So 0, because remember, whenever you have an exponent outside, you multiply 0 times 0, 0. And y to the 0th power, you distribute the 0 to here. 0 times 0, that 0 stays. And then z to the 8th to the 0th power. Whenever you have an exponent outside the parenthesis, you multiply. 0 times this 8 is 0. So if I were to simplify, I distributed the 0 to everything. Everything is raised to the 0th power, which is the same thing as saying there's an invisible 1 in front of this. This is gone, and 1 is my answer. Okay, now we're getting towards the end of the notes. Since we're getting towards the end of the notes, I give you the last thing, and it's about negative exponents. Now, negative exponents, think of this. Think of a boop, flip it upside down. Whatever your numerator and denominator is, it flips. And then when you flip it, the negative exponent is gone. Conceptually, you take the reciprocal of the term. So I say this, what is x to the negative first? And then I give you the answer. But before I give you the answer, think of this. X to the negative first, technically there's an invisible 1 is your denominator. So if I take the reciprocal, I go, boop, it becomes 1 over x to the positive first, and that's my answer. I am taking whatever term has my negative exponent and I'm putting it in the denominator. If I already have something in the denominator, I put it in the numerator and it becomes positive. Look at the next example. I ask, what is x to the negative third? Well, here's my negative exponent. Take this, boop, flip it, and it becomes 1 times x to the positive third. That's your answer, x to the positive third. All right, a little more difficult. I give you an actual practice problem. 5x to the negative second, y to the third. What I'm going to do is this. I'm going to make this a little more difficult. I'm going to make this a negative 5. I'm going to see, can you simplify this? Pause it and see if you can. All right, so those of you guys that are actually doing this, I know that when you pause this, you probably flip this negative 5. That's incorrect. The reason why is, what's the exponent next to the negative 5? There's an invisible 1. You never flip a negative exponent, a negative number before, so don't need to start now. Look, I'm going to make, whenever you have a negative exponent, and at least somewhere in the problem, make a blank fraction and go step by step. This, and I'm going to put this all over 1. Negative 5 to the first power stays negative 5. You've never done anything with the negative 5, so just leave it. If this was a negative exponent, yeah, then you'd flip it. But just because a number is negative doesn't mean that you flip it. All right, x to the negative second goes boop, and it goes on the bottom, x squared, and it becomes a positive, and then cancel it out. Y to the third is a positive exponent, so it just stays right where it is, and this is the simplified answer. Okay, now 3 questions for you guys to do. What I'm going to do is I'm going to go through these 3 questions. I would encourage you right now to pause the video, do the first one, and then watch me explain it right now. And then right after I finish explaining, pause the second one. Same thing for the third one, and watch me explain it. See if you got it right. All right, so for the very first one, I'm going to distribute that cube to everything. 2 to the third times n to the third times, see how I have 4n to the negative first? I'm just going to break it up. Times 4 to the, I'm going to put an invisible 1 times n to the negative 1. I'm doing this so I can break everything up nice and even. Now I'm going to simplify. I have 2 to the third, which is 8. And then I have 4 to the first, which is 4 with an n to the negative first. I just want to simplify my numbers. Now I have a negative exponent, so I'm going to make a blank fraction. And I'm going to go step by step. 8 is going to stay on top. 4 is going to stay on the top. 8 times 4 is 32, because I multiply these 2 numbers together. N to the third stays on top. The reason why I say it stays on top, because there's no negative exponent. N to the positive first, it goes in the bottom. Now I can simplify. 32 n to the third times n, I can get rid of 1 in here, leaving me with 2. And this is my answer. Some people might say, wait, couldn't you have just done this? Couldn't you have done 8 times 4 is 32? And when you multiply bases that are the same, which this is and this has the same base, you add the exponents. 3 minus 1 is 2. So wouldn't my answer be 32n squared? That's exactly it. And it doesn't matter what you do to derive derive your answer. As long as you do it correctly, you're good. Okay, next one. Pause the video. See if you can do the second one from the notes that you should have in front of you right now. Okay, so you should have paused the video, seeing if you could have done the second one. I'm going to write everything out. I'm going to do a couple steps before. 3 times 2 on your numerator is 6. I'm just going to list the exponents y to the third times x times y over 12x squared. I have y to the 0. Y to the 0 is equal to 1. So technically it's times 1. This y to the 0 replaces with a 1. But 1 times 12x squared is just 12x squared. So conceptually, whenever you have anything raised to the 0th power, you can just get rid of it. You don't need it because it's just multiplied by 1. Okay, now I'm going to simplify. First off, let's deal with my numerator. And you don't have to go in this order. You can go in any order you want. Y and a y to the third is going to give me y to the fourth over, with an x, over 12x squared. Now look, 6 and 12 reduces to 1 and 2. This is 1/2. I have 1x here. I have 2x's here. I can get rid of 1 on top, leaving me with 1x on the bottom. Look, this becomes this. Instead of there's 2x's here, think of this as like this. Boop, boop. And I just cancel out x and x, leaving me with 1 left. And that y to the fourth stays. Now if I clean it up, I don't need to write 1 times y to the fourth. It's insinuated that that 1's already there. So there's your answer. Y to the fourth over 2x. Okay, very last question. All right, very, very, very last question. I'm going to distribute that -3 to the 2, and I'm going to distribute that -3 to the m. 2 times -3 is -6, because there was a m squared, times a -3 on the outside, over 100x to the 0th power, all becomes 1. All right, now look, 2 to the -3rd flips. I'm going to make a blank fraction. I'm going to go step by step now. 2 to the -3rd flips. It goes boop. It becomes positive. M to the 6th, this dude flips. And whenever there's nothing on top, there's technically a 1. This 1 doesn't have anything to do with this 1. This 1 was on the bottom to begin with. And then 2 to the 3rd is 8. So your answer is 1 over 8m to the 6th.